what is the sampling distribution? Okay, so the sampling distribution is the set of all possible sample means from a population. Okay, so if we had a population, and you're going to do get onto the computer and see a computer simulation of this that is going to show you some graphs. Okay, so what it shows is that we have our sample. Okay, and every time we take a sample from the population, let's say, for example, we're testing the body temperature of students at BYU Idaho. Okay, so we do 100 students every time we do a sample. Okay, so maybe the first time, the mean of the first 100 students is, let's say, 96.0 degrees. Okay, so what happens is we get one box right there. And you take another 100 students, and it's not going to be exactly the same, but maybe it's, in fact, maybe it's significantly higher. Maybe it's 97 degrees. Okay, now we take another 100 students, and we find that it's 96.5. Get a box there. Okay, as you take the more and more, you're going to get a bunch of boxes. Sometimes it'll get exactly the same. Sometimes like this. And what happens is the shape that this ends up making, see that shape right there, that is what the sampling distribution is. What is the shape of the sampling distribution of the sample mean when the data are normally distributed? Okay, the answer is very simply normal. When it's normally distributed, when the data are normally distributed, then the sampling distribution will be normal as well. Okay, so if that population is normal, then we know we'll come out with a normal sampling distribution. Question 3. What is the shape of the sampling distribution of the sample mean when the data are not normally distributed, but the sample size is large enough? Okay, so if you get a large enough sample size, we normally go about 30, but it depends where it's at. The larger the sample size, the closer to normal this will be. And so it's approximately normal. And that is according to the central limit theorem, which we'll talk about in just a minute. Question 4. How does the shape of the sampling distribution of the sample mean change when the sample size is increased? Okay, so as the sampling size increases, as you collect more, so say maybe instead of 100 students sampling from campus, maybe you sample 200 or 300 or 1,000. As that gets bigger, it gets closer and closer to normally distributed. Question 5. What is the difference between the central limit theorem and the law of large numbers? Okay, so the central limit theorem says that as the sample size increases, the distribution of sample means will become more approximately normal. It will get closer and closer to normal. Okay, the law of large numbers, on the other hand, says that the standard deviation of the sample means will get smaller, or in other words, will get closer and closer to the true mean. Okay, so central limit, you're talking about the shape. It'll be approximately normally distributed. The law of large numbers says that your mean will get more and more accurate. Question 6. When is X bar normally distributed? Okay, so 2 reasons it could be normally distributed. The first is that it comes from a normally distributed population, and the second is if the sample size is sufficiently large. Okay. It says randomly select 5 of the 30 salaries and compute the mean. Okay, so I'm going to come over here to a random number generator. I just searched that on Google, and this was the first hit. It seems to be pretty reliable. My minimum will be 1, and my max will be 30. As you can see on the worksheet, they've nicely numbered the different salaries of the finance people. So, generate. I got 8, which corresponds to 47,300. I'm just going to type these into Excel to make the mean pretty easy. Generate 13, which is 52,800. Okay, I'm going to generate another one, 21, which correlates to 52,900. 2 more. I got 8 again, which is 47,300. Okay, and then one more time, I got number 19, which says 43,600. Okay, and then I can find the average here on Excel. There it is. These ones. And my average was 48,780. Okay, so 48,780. And I have an image here of where that would be. So I'm going to kind of just try and mark about where that would be. So 48,780. So 48 and then 780. So approximately right there. Okay, so that's where mine turned out to be, and you can do yours on there and see where you come out. Part B asks you to label or put an X or mark the spot anyways, just like I did right there, where yours is at. And then part C says, does your sample mean appear to be unusual? Explain why you think it is. So this will depend on where yours is at. Mine doesn't appear too far from the middle. I would think the middle is probably about close to 47,000. So I would consider mine normal. There's nothing that we're looking for specific. If you're out here and farther out, then we would think that yes, you are. But there's no wrong answer there. A. What is the shape of the distribution of sample means for all such samples? Okay, the sample distribution will be normally distributed. And part B tells us why. Because the parent population is normally distributed. Remember, there's one of two ways. One, your sample size is large, or two, the parent population is large. So because, our parent population is normal. So because our parent population was normal, we can say that the sample distribution of the sample means will also be normal. Part C asks, what is the mean of the sampling distribution of sample and mean scores for all such samples? Okay, well, the mean of the sample means, so if you remember, what we're talking about here is taking multiple samples. So 100 students from BYU, Idaho, doing that multiple times, selecting randomly different sets of 100. That mean, the mean of all of those groups, will be centered around the true mean, which is 529, which was given to us in the problem. And finally, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? Well, the equation for the standard deviation is sigma divided by the square root of n. And remember, sigma represents the standard deviation, and n represents the sample size. So with 113 divided by our sample of 10, type that into the calculator and we get 35.754. Okay? So remember, that is the equation to find the standard deviation of the sample mean.